Hi, this is video 6.4. We are now looking at graphing linear equations. This is the introduction in page 1 up 2. So this video will actually have 2 pages that go with it. Just saying. All right, 3 plus a number is 12. What is the number? Can you write that out of the equation? Okay, 3 plus something is 12. It'd be like 9, right? Yeah, you knew that. Can you write this out as an equation and solve it? So x, use whatever letter you want. Oh, no, let's do it right. It says 3 plus a number, so 3 plus, I'll make it nice. I'll use n because it says number is 12. So is equals. All right, can I solve it? Minus 3, I want isolated n is equal to 9. If that looks scary, you should find the videos on solving one-step equations and go back through them. How many answers are there to this equation? Can you think of any other number that 3 plus that number gives you? No, there's only one answer. And yeah, I'm gonna leave it at that. I was gonna go off onto some tangent there, but that's it. One answer, done. All right, 2 numbers are added together to give you 12. What are the numbers? I don't know. 5 plus 7 is equal to 12. Can you think of some other ones? 6 plus 6 is equal to 12. 0 plus 12 is equal to 12. How many answers are there? Lots. That's very unmouthy of me, but lots. If you want to get technical, you probably say they're an infinite number, but go with lots. Okay. Determine 3 different sets of numbers that add up to 12. Well, I gave you some there. You could get, let's do it that way. You could be a crazy person. You could use negatives if you want to. So negative 1 plus 13 is 12. How about 2.5? No, that's silly. 2.5 plus 9.5. Don't judge me on that little pause there. It's 12. And I'm just getting lazy. 1 plus 11 is 12. All right. Do you think there's more than 3 sets of numbers that would work? Yeah, of course. Right? I just showed you that negatives work. I showed you decimals. And then I just had like regular, those would be natural numbers. Oh, whole numbers. So I used a 0 up there. All right, yes, there's a lot. As an equation, the 2 numbers add up to 12. Keeping organized nicely with a table just like this. You are going to make an awful lot of these tables in the next little while. All right, so what you do is you pick any number you want for the x value. So I'm just going to pick 2, try and do something else. Okay. And I even said don't use the numbers. So then I've got x plus y is 12. So 2 plus y is equal to 12. And I want to get the y by itself, so I'm going to subtract 2. So that's pretty small. And I get y is equal to 10. And then I put 10 over there. And then I draw a line across. And that's about as hard as it gets. So you can pick any number you want. Right? If I want to do, I don't know, 15. I don't know why, but I'm going to 15. X, so where the x is, right? So all I'm doing every time is I'm substituting for that x. So 15 plus y is equal to 12. Minus 15 minus 15, y is equal to minus 3. Yeah, I was just doing that to show you that we can have some options. I could use decimals. Sure. I don't know, 1.78. Why? I don't know. It's just coming in. It's okay. So 1.78 plus y is equal to 12. See, now I've got myself in trouble. Oops, sorry. got my handy dandy calculator. So minus 1.78, minus 1.78, 12 minus 1.78, 10.22. If I wasn't trying to, for lack of a better phrase, show off right now, I wouldn't be bothering with these ones. I would just use nice little whole numbers so that when I generate the other half, it's all good. All right, each set will generate an ordered pair of the form X and then Y. Write out the ordered pairs you just did. So I got 2 and 10. I got 15 minus 3, 1.78, and 10.22. And then if we go up here, it's 5 and 7, and 6 and 6, and 0 and 12, and negative 1 and 13, and 2.5, oops, comma, 9.5. And I just realized you couldn't see those last ones that I wrote. Okay, so all I did was make them into ordered pairs. Now for these ones, we clearly have an X and a Y. With the ones we were doing up here, I just went X was my first number, Y was my second. Because, now this is actually very key. Because this is X plus Y is 12, the order that you add them, the order that you put the numbers in the brackets really don't matter. Because you know what, if I have 2 and 10, 10 and 2 is also going to be on that line because 10 plus 2 is 12, just like this is. Doesn't always work. This is only because this is an addition question, right? If it was a subtraction question, then you wouldn't be able to flip those. Okay, anyway, continuing on our next page. So, here we go. This says, plot the pairs and points that you generated in question 4 and question 8. All right, question, yeah. So here's one of those times where my graph probably should have made it bigger, or maybe I should use a number smaller than 12. Anyway, here are my points. So X is my first one, so 10 and 2. And then I've got 2 and 10. Okay, can you see my problem? Not to mention 2 down here on you. I don't have 15 on here, but you know what? I've got a lot of points, so I'm just going to skip that one. Now I've got 1.78 and 10.22, which is also off my graph. So I'm going to plot it, but I'm going to make it like a little star. So if that doesn't line up with everything else, I'm not going to worry about it. Remember I said I was just kind of showing off when I did that one? Let's go with the simple ones. 5 over, 7 up, 6 over, 6 up. Oh, 0 and 12 don't work. Negative 1 and 13, 2.5, and 9.5. All right. So if I did that, it looks like these points form a line. And I can see that when I plotted that one, this one was off by a little, and that one I was estimating, but you can see the other ones are nicely through the corners. Okay, and then it says use a ruler to connect the points. By the way, if your points are not all in a nice straight line, something's wrong. When you do these calculations, they should always be the same place. Okay, write the coordinates of 5 new points on the line. All right, well, this one's on the line. And that is 4 and 8. And let's do this one. That is 7 over and 5 up. And This is 8 over 4 up. 9 over 3 up. How many do I need? I needed 5. 1, 2, 3, 4. Now let's do this one here. That's 3 over 9 up. Okay. So, what do you notice about all these points that I wrote? If you add them up, 3 plus 9 is 12, and 12, and 12, and 12, and 12. So there's 2 ways to look at it. I guess the easiest thing to say is any point that you pick on this line, when you add up the coordinates, it's gonna give you 12. So whether it's the points that you started with drawing to give you the line, or whether it's the points I'm picking out afterwards, they're still always, always, always gonna add up to 12. So what conjecture can you make about all the points on the line? The coordinates will always. Now that's for, oops. I really wish I had someone watching this live and then they could say, hey, Joanne, we can't even see what you're writing. Okay, so for this specific line, if you add them up, it'll always add to 12. Generally, any point on the line, let me do better, the coordinates. Notice I spell coordinates different up there. There we go. Any point on the line will satisfy in other words, if you substitute and that's an important thing to remember. Okay, so if you need, if you have a line, any set of points that you pick on there is going to work. All right, that is the end of that video, 6.4.